Hi everyone, it's Jeff from Transient Specialist. Thanks for joining us today. Today we're going to be spending some time on ISO 7637-3 testing using equipment from both EMTest and TESIC. We'll start by going over a little bit about the equipment, then we'll go ahead and we'll take a look at the setup, and then finally we'll start up the ISO.control software. ISO 7637-3 focuses on electrical transient transmission by lines other than supply lines, which is commonly data or I/O lines. We're going to be looking at equipment for the capacitive coupling clamp CCC method and the inductive coupling clamp ICC method. We'll be referencing the user manual and data sheets for the equipment, which can be found on our website. I'll also put the links in the description below. Let's go ahead now and let's start by taking a little closer look at the equipment. Now we're looking at the equipment commonly used for ISO 7637-3 inductive coupling clamp ICC method. Starting on the left, we have the TESIC CIP 9136A inside of our calibration fixture, the PCJ 9201. To the right of that, we have the EMTest UCS 250, and in front on the left of that, we have the EMTest MN-CIP 9136. The MN-CIP 9136 impedance matching adapter is designed for use with the EMTest UCS 200N series of automotive transient generators. For the TESIC NSG 5500 series, the INA 5580 is used, which you can see in the front on the right side of our UCS 200N. These impedance matching networks are used during the level setting and are adjusted individually for a particular BCI probe. Let's go ahead now and let's take a look at the setup for ISO 7637-3 testing and level setting using the ICC method. Alright, now we're looking at the inductive coupling clamp information on page 54 of the user manual for the EMTest UCS 250. Taking a look at the top, we have a brief overview, and then just below that we have a table for the requirements for the pulses with the different systems. Below that we have a setup diagram for the ICC calibration or test level setting, as well as testing. Taking a look on the right now, we have a brief note about the polarity. When the polarity needs to be switched, the BCI probe is rotated 180 degrees with the adjustments made to the calibration fixture. Below that, if we scroll down, we have an example of the pulse measurements from our calibration fixture. Let's go ahead now and let's get this set up with our EMTest equipment and let's take a look. Now we're looking at the setup for the pulse level adjustment, and it's based off figure 6 of ISO 7637-3 2016, as well as the supporting documentation. Starting from the left, we have our transient generator output going to the MN-CIP 9136 impedance matching network. We have our impedance matching network connected to our injection probe, the CIP 9136A, which is placed in the PCJ calibration fixture. We have the shorting adapter connected to one side of the PCJ calibration fixture, and we have the other side going to our oscilloscope. Once the waveform is captured using the oscilloscope, the necessary adjustments will be made to the testing criteria, typically using the software, which we'll walk through a little later in this video. Once the levels have been adjusted and verified, testing can begin, which is described in section 4.7.4 of ISO 7637-3 2016. Let's go ahead now. Let's take a look at the test leveling setup for the capacitive coupling clamp method. Now we're looking at the transient pulse level adjustment in section 4.5.3. Let's go ahead, let's start from the left and let's work our way right. On the far left, we have our UCS 200N generator which is connected to our capacitive coupling clamp. On the right side of our capacitive coupling clamp, we have the KW50 50 ohm attenuator, which is connected on the opposite side, and then we have that attenuator connected to our oscilloscope. Once the pulse level adjustment has been completed, testing can begin. Let's go ahead now. Let's take a look at the ISO.control software. Now we're looking at the ISO.control software. Taking a look at the top, we're currently in the standard mode, and we have ISO 7637-2 loaded. Looking in the lower right-hand corner, we have our UCS 200N icon, just letting us know we do have communication with the transient generator. Let's go ahead now and let's load ISO 7637-3. To do that, click Standard Tests in red at the top. And as you can see, we have our standard selection pop-up. As you scroll your way through it, through the international ISO, we're interested in ISO 7637-3. And we're interested in the 12 volts. So let's go ahead and let's select OK. As you can see, we have the different pulses here, as well as the associated test methods. We have our DCC and CCC at the top using the fast pulses, and then below that we have the DCC and our ICC methods with the slow pulses. Let's go ahead and let's take a look at the slow pulses using the ICC method. As you can see, we have our test pop-up here, and we have the test criteria along the left, a graphic representation in the middle, and then we have our level on the right. All the way at the bottom of the menu, we have our Start button. During the level setting process, the level and time between pulses could need to be modified, as well as the number of pulses. Let's go ahead and let's change the time between pulses to 4 seconds to allow us to set our scope and measure the waveform. Now, let's go ahead and let's change the number of events from 600 to 5. And then we'll hit enter again. Once we verify a few waveforms with our oscilloscope, we can change the necessary level to ensure we're meeting ISO 7637-3 requirements. Alright, that should complete the video today on ISO 7637-3 testing using equipment from both EMTest and TESIC. We started out by going over a little bit about the equipment, then we moved to a few different setups, and finally we went ahead and took a look at the software. We hope this video has been useful, and please keep us in mind if you ever need to rent equipment designed for ISO 7637-3 testing.